Hi, everyone. Thank you so much for joining us today. We're going to just give a few moments before we get started, give everyone a chance to log into our Zoom webinar for today. Great. It looks like we have a good number of people jumping in. We'll just wait one more moment. Okay, great. Thanks, everyone. Hi, my name is Courtney Brown, and I'm a Senior Marketing Manager here at EDB. I'll be your host today for our webinar, How to Properly Backup Your Data. I'm joined by Lætitia Avrot, Senior Database Consultant at EDB. Before I turn it over, I'm going to go through a few housekeeping items. This presentation is being recorded. We'll be sharing the recording along with the slides after the broadcast to the email that you used to register for the session. All of your lines are currently muted. If you have a question, please feel free to submit it in the question panel. We expect the presentation to last most of our time today, but we'll allot any extra time for Q&A. If we don't have time to address all of your questions, we'll be sure to follow up afterwards. And with that, I'll hand it over.
Hello, everyone. We will speak about backup, and what's important is what is a backup and what's not a backup. And we'll see, I hope, that the answer to both those questions is my favorite answer for technical question. It depends, because having backups without context about what you're trying to achieve is totally useless. So we'll see how to find the right context, how to define what backup you need and why you need a backup. Actually, I'd say that if you have backups without taking any effort about trying to restore it, your backup are totally useless. It's the thing that we call the Schrödinger backup, because we've seen so many companies having backup but not able to restore it, and so losing data. So that's a problem. But first, let me introduce myself. My name is Lætitia Avrot. Don't worry if you can't pronounce my name correctly. I know it's very difficult if you're not, if your mother tongue is not French or Romanian or Spanish. Anyhow, I'm a senior database consultant at EnterpriseDB, and I'm also a Postgres contributor. Actually, I'm also the PostgreSQL Europe Association treasurer. So I'm taking care of money for conference all across Europe. So we will speak about why we would want a backup. Normally, we want a backup because we are trying to avoid data loss. And then we will step into several things that could be appropriate as backups, as long as we know how to restore it and as long as we understand the problem and the data loss that can happen with this kind of backup or copy of data. And after that, you'll be able to ask your question. But if you have a question that's really important, please feel free to, I will try in the middle to let you ask your questions, because I think that questions are better in context, just like backups are better in context. So first, let's try the first thing, data loss. So we will just eradicate the first thing. There is no such thing as zero data loss. So that's a discussion I had with Robert Haas, who's a chief database scientist at EDB. If the Death Star shows up and does to Earth what it did to Alderaan, practically everybody is going to lose data. And that's fine, because I'm pretty sure that we wouldn't care about losing data in that case. What this means is you need to consider if the losing data is really important in each and every scenario where you will risk to lose data. When I say that losing data is always an option and losing zero data is not possible, I mean that in some case, you won't be protected and it's okay. Obviously, you won't in 2021 send your data to Mars so that they're protecting against Earth exploding. But it will be so costly that your company will be bankrupt because of backups, and that's not what you want. So you need to embrace the fact that there is no such thing as zero data loss. I'm sorry about it, but for now, that's not possible with an RDBMS like Postgres. It's what I call a unicorn hunt. And I'm pretty sure, as I said, that should the Earth explode, it wouldn't be a problem to lose your data. So that's not possible. Let's try to solve the problem another way. There are several questions of context about your project or your applications that will lead to the choice you will need to have for your copy of your data. The first thing you need to know is, are you able to recreate lost data or lost transactions? Some applications log everything they do, and from these logs, they are able to recreate transactions. Some applications get data from flat files and are able to reload them should them lose them. So for some application and project, recreating data or transactions is not a problem. Then there's another question I'd like you to ask is, how much costs 1 second, 1 minute, 1 hour, 1 day, 1 week of data loss? For some companies, losing 1 week of data is something that they can afford. Some others can't afford to lose something like 1 hour or 1 minute or even 1 second. That will be more difficult to reach, but we can try to reach it. And then there's another question, because having a way to recreate your data or your transactions is great, but how much time can you afford before the company is bankrupt? How much time can your application be down without it being a very serious problem for your company? And how much time can you afford to recover on top of having recreated your data and transactions? So I'd like to introduce you with two concepts. It's very common concept in IT. The first one is RTO, Recovery Time Objective. It is a targeted direction of time and a service level within which a business process must be restored after a disaster or disruption in order to avoid unacceptable consequences associated with a break in business continuity. And RPO, which is the recovery point objective, it is defined by business continuity planning. It is the maximum target period in which data or transactions might be lost from an IT service due to a major incident. Other quotes are from Wikipedia. So it means that there are two things you need to consider. It's how much data are you ready to lose, because we've seen that zero data loss is not an option. And even with that thought, you need to think, how much downtime can you afford? That's the two constraints that will allow you to find the right solution to not lose too much data. So just before I spoke about an unlikely scenario of the Earth exploding, but there are other scenarios that can lead to data loss. First one is data corruption. Data corruption can sometimes spread through standbys or even to physical backups. Host failings, that's something that happens all the time. Network failing, again, that's not that uncommon. Any massive disaster, fire, earthquake, nuclear bomb, tsunami, tornado, and so on. And thanks to OVH, we know that fire in a data center can happen. Human destroying data deliberately or by mistake, that happens, and I've seen several cases where it happened by mistake. I've never seen a human deliberately destroying data, but I'm pretty sure it can happen too. So for all the scenario, you need to ask yourself, am I ready? How much data am I ready to lose? And how much downtime am I ready to have? Depending on that, you will be able, with your budget, you will be able to to design a backup architecture and a restore architecture. Because a backup is totally useless if it's not tested regularly. What a test of a backup says, it says that today I was able to restore that backup. So today that backup was good. I don't know for tomorrow. Let's jump into the first kind of thing that could be called a backup, depending on how much data loss you're ready to have. So it's called logical exports. It is an export of data in a format that can or cannot be portable. And what's important is it's a snapshot of your data at that precise moment. Examples of logical exports are CSV file, SQL files, any flat files, text files, and so on. The Postgres core recommended tool to create logical exports are pgdump to export data from only one database, and pgdump all for exporting data from the whole cluster, not only one database. So when should you rely on logical export only? And I try to emphasize that all the following condition needs to be fulfilled. You can't just rely on one. So the first one is losing data between your export time and the stopping point of the disaster is not a problem. That's really important because there's no way you can recreate the data between that export time and the stopping point. Having downtime during the restore and post-restore operations, like vacuum full analyze, is not a problem. It means that you know how much time is needed to restore your data and to do the post-restore operations. That's really important because if you don't test, you won't be able to know that time, and so you won't be able to know if your downtime is acceptable or not. And the third point is you solemnly swear you'll test the restore and post-restore operations frequently. A lot of people use the word regularly. I prefer using frequently. And when I say frequently, I mean something like once a week at least. You need to really be sure about what you're doing, and a database can change drastically. It can grow up and can take way more time to restore and so on. So you need to be very careful, and so testing everything weekly seems a good option. So let's try an example. You export all your data every day at 3 a.m. Import time takes 2 hours because you've tested it and you know. Post-restore operations take 1 hour to complete. An incident occurs at 3 p.m. How many transactions will be lost? When will the database be available again? So that's very simple to calculate. All transactions between 3 a.m. and 3 p.m. will be lost. It means 12 hours of lost transactions. And then the database should be available around 6 p.m. because you will have 3 hours of downtime, 2 hours to import, and 1 hour to do the post-restore operations. Just for your information, depending on the amount of indexes you might have, import time can be very, very more important than the export time, because during export, we will just export the DDL to recreate the index, but we won't export the data in the index. While during import, of course, you will have to recreate the indexes. That can take a lot of time. About the post-restore operations, as you know, when you load a lot of data, it is advised to use a vacuum full analyze to gather statistics and reduce the bloat. It's really something that I encourage you to do. Of course, your database could be up before, but it will be slower. I really encourage you to do the things properly and have 3 hours of downtime instead of 2 hours of downtime now, but several hours later when you will try to get rid of the bloat, and several of slow down during your transactions because the statistics are not up to date. So what do I need if I want to rely on logical export only? You need to check regularly that data loss stays within acceptable bounds. So let's say you're exporting once a day, it means that you're ready to lose at most 24 hours of data. But I'd say that until your backup is tested, you can't be sure, because maybe the backup you did at 3 a.m. last morning is not restorable. It's corrupted. And so it will make the data loss even bigger. The only way to check it is to test. So as I said, and I'm sorry, I have to repeat it because I go to customers and they'll never do things like that. So try to regularly import the generated export to check that it's not corrupted. The restore duration is still okay. And the post-restore operations duration is still okay. It's not because it was 2 years ago that it's still true. You need to reevaluate that regularly because your project is changing, your database might be growing, and so on. So you need to reevaluate regularly. How to use pgdump, pgrestore? So pgdump is the core tool with Postgres to export. If you want to export a whole database, you will use the connection options, the classical connection options for Postgres client, like -h for the host, -p for the port, -U for the user, and then the DB name. So with that, you will export everything in the database. Just keep in mind that some objects like rows and table spaces are not stored on the database level. They're stored on the cluster level. To be able to export table spaces and users, you will need to use the pgdumpall utility. There is a special -g flag that will allow you to export only the global object, table spaces, and users. If you want to export with pgdump, there are several formats, but 2 are important. The first one is plain SQL and is a default. If you do that, so it's with the flag -FP, please name your export file something .sql so that you remember it's an SQL file. You won't need pgrestore to restore it, actually. And if you use the custom format, which has several advantages like being compressed by default, So it's the -FC flag. I encourage you to name the file with .dmp or something that will evocate in you the fact that it's a custom format. It's not SQL. Of course, you can export a single table or schema using the -t or -n option. And you can also export DDL only. DDL is for data description language. It's a subset of the subset of SQL that creates objects, alters them, drops them, and so on. I see there are 3 questions, but I can't see them. Courtney, can you help, please?
Yes. So the first one is how to restore the PG base backup if we have the PGX logs present in different directory when using the flags X or XS or XF.
This is, I will answer that later because it's not about logical export. PG-based backup is a physical backup. That's totally different, and that's more complex, and we'll see why later.
And then someone said they're using pgadmin 4. Do you have the equivalent ways to use those command line to a graphical user interface like pgadmin?
Yes, I don't like using GUI tools. I use and rely heavily on command line tools for several reasons. The first one is when I do that on my terminal, I have Tmux, which is a terminal multiplexer installed, and there is a great extension to this terminal multiplexer, which is called Tmux logging. It will capture everything I do, my commands alongside with the result of them, so that everything I do is recorded. It's crucial to me because it's not my host I'm working on, it's my customers. So I want to be able to look down at what I did, should I made a mistake, or just to be able to say to the customer exactly what I did. And at 2 or 3 a.m. in the morning when you're cold, you're really, really happy to have this kind of feature. Should I use a GUI tool? It will be more difficult to record what I'm doing. But yes, it's possible to do it that way. I'd rather use a command line terminal because of traceability.
Someone else is asking if you can give examples of good practices around how to manage user/role in backups.
As I said, if you want to rely on logical export only, it's a good practice to regularly do a pgdump all with the -g flag so that you can export the roles creations and the tablespace creations and all the alter users and so on.
The other two, so if you see where the number is showing up for Q&A, if you click on that, it will pull up the comments because 2 of them are about format specifically, so reading them might.
The problem is I can click on the button, but nothing happens.
Okay. Well, I'll just read the other ones that are coming through, and we can circle
Or
back.
you can send them to the chat because I can see on the chat.
Okay. Someone else said, do you recommend using logical backups on a really big database, more than 1 TB of size?
It depends. As I said, it depends how much data you're ready to lose and how much downtime you're ready to afford. Of course, exporting a 1 terabyte database with pgdump will take a lot of time. But if you're okay to have a lot of downtime, should something horrible happen, we're fine. That's your choice.
Someone wants to know if there's an option to run pgdump just to check for database corruption and not to run an actual export back.
Yes, pgdump, the great thing with pgdump is that it will read each and every page on Postgres. So it will detect corruption. I'd rather rely on checksum for database corruption, but still you will need to read all the pages. So that's a trick to use pgdump to read all the pages and redirect the output into /dev/null if you can't afford the storage, so that it will read everything, and should something be corrupted, you will know.
Okay, it looks like some of the other questions are not specific to where we are right now in the presentation, so we can circle back to them.
Okay, I'll keep going. So about importing, if you used a plain SQL format, just use PSQL-F to give a file and your file. If you use the custom format, you need to use pgrestore. pgrestore works in two different ways. The first way is connected, so it will connect to the database. It will create the SQL and play it on your database. The other mode is a not connected mode, where you won't give any connection options to pgrestore. And in that case, it will issue on the it will display on the standard output the SQL recreated from the dump. Of course, if you have everything in a dump, you don't have to restore everything. You can use pgrestore to sort what you want or what you don't want. So you can still use the -t, -n, or just restore DDL only with -s and so on. What about standbys? So what is a standby? So first, a standby is also called replica, princess, worker, secondary, or tertiary, depending on the terminology you rely on. I love the queen, princess, worker terminology. It's an analogy with a hive. So you have the queen bee, whose work is just to work. And then you have the workers that will work for the queen, and you have the princesses. And the only role of the princesses on the hive is to be ready should the queen be dead. And that's why I love this analogy, because you can have a standby that will serve read query. In that case, that's a worker. You can also have a princess, which is, to me, a standby that does not serve read query. It's there just to be ready to take over the queen should the queen die. And it helps understanding that you can't have both. A good princess can't be a worker at the same time. A good worker can't be a princess at the same time. So what is a princess or a worker? It's another instance totally identical to your queen node, but there are differences. The first one, there are two kinds. First one is physical standby. It means that all your binary files from your queen are totally identical to your princess. There is also logical standbys, where the files might not be the exact same binary ordering, but you should find the same data when you will query the data. A standby is in recovery forever. It means that it's applying all files, and it can be open for read-only queries or not. When should you rely on standby only? And that's very simple. Losing some or all of your data is not a problem. So let's say that we have a former employee that connects to the database and drops it because maybe they're very angry or whatever. Or a hacker enters your system and drops the database. Or the DBA removes the PG data directory on the primary by mistake, while trying to rebuild the secondary that's corrupted. So you don't have the secondary because it's corrupted, and the primary is removed. You might say that a DBA won't be able to do that. Well, it happens, believe me. So these cases shows that if you rely on a standby only as a backup system, it's okay, but only if you're ready to lose some or all of your data should one of these scenarios happen. Because the data you will use if someone drops the database is everything. There is no copy. Because everything you do on the primary is replicated to the secondary. And most of the time, there is not enough time to prevent it going to the secondary. So this scenario are really real scenarios that can really happen, and the probability is not so low. So I really encourage you to think over if you think that you can lose all your data, you can go without other backups than your standby. Maybe for some application, being up and having less downtime is more important than losing data. It can happen. For those corner use cases, using the standby is okay. As I say, the correct answer to what kind of backup do I need is it depends. How to set up a standby. So here are the high-level steps. You need to make the Queen node ready for replication. There are some parameters to set, and in particular, I really encourage you to put archiving to on. Then you need to take a physical backup of the node, and you will restore the physical backup on the Princess Worker node. Then you will change some settings to the Princess Worker so that this node knows that it's not a queen. Then you will start the Princess Worker node in Princess Worker mode. And then you will check that the replication is working fine. So these are really high-level steps, but it's not that complicated. It might be a little long if you're not used to it, but with some practice, it will go very easily. Do we have questions about standbys?
One minute, let me pull out what came through. Let's see. There's a lot of questions about when to use PG restore versus PG dump in terms of pros and cons. That was one question. One was about what's faster.
Again, what's faster? It depends. You need to test to be sure. It depends on your hardware. It depends on the kind of the database you have, the kind of workload you have. I can't say it that, so easily. It will depend on your database.
Someone wanted to know, how do you check the status of the Queen to Princess replicas? It was the last bullet point.
You have a view PG stat replication. You just need to query it. I will keep going because I haven't seen time, but I need to keep going if I want to go to the end of the presentation. So about woes and recovery. So woes are files where, and we'll see how they work. Let's say we have a user sending a DML query, DML for data modification language, it's upgrade, delete, or insert, to an instance being a memory with process. Here we have data files. The first thing the instance will do is take the data from the data file into the memory. Everything going on with an RDBMS is going on memory for performance reasons. Then we will change the data according to what was asked. And just in that case, the memory is called dirty. So if you hear someone talking about dirty buffer, it just means that the data you have in memory is different from the data you have in the data file. And then the user sends a commit, or it's in auto commit mode, whatever. Just before answering the user, we will store this modification in the WAL file. The WAL file is a sequential file, so it's easy to read into it, and it's fast. And then we will say to the user, we're fine. Everything is fine, don't worry, we won't lose your data. And from time to time, there is an operation called a checkpoint, where we will tell data from the memory into the data files. And then the memory is not dirty anymore. So, but what happens if there is a crash before we were able to take the data from the memory into the data file? So we have this situation. We have the WAL file here with two red squares that are different from the data files we have here. First thing the Postgres will do when it will start, it will look at the last checkpoint. And then it will look at operation happening after that last checkpoint in the WAL file. And then it will take the data into memory and issue a checkpoint to secure the data into the data file. And after that, the database will be open again and you'll be able to use it again. That's how we ensure that we don't lose your data while still having good performance. That one is an important one because now we use VM or VM is the most common thing. And with VM, we have something called VM snapshot. And also on the storage point of view, we have things called storage snapshot. So what it is, it's a set of files at one point in time. Offline snapshots are very fine. It means that you stop the database, then you do the snapshot you want, and then you start the database. If you do that, you will have a set, you won't have any problem with your set of files. The problem nowadays is that it's really difficult to stop the database. Most of the time, people want the database to be running at all time, so that we need to do online snapshot. And the problem here is that it operates on a layer below the database, because you see you have the VM, the storage, the OS, and then the database. And what you need to understand is, from the file system point of view, an RDBMS have most likely inconsistent files on disk. So you need to remember to put your database in backup mode to not rely on luck for your recovery, and to archive all the WAL files between the beginning of your snapshot and the end of your snapshot. That's really important, or else you won't be able to recover. But you'll see it because you will test your backup. So when to rely on VM storage snapshot only? All the following conditions need to be fulfilled. Again, I can't stress it enough, you can't rely only one or two of this, you need everything. So the first thing is you really understand what you're doing, and it means that you really understand under the hood how Postgres is working. You don't want another option because it can't satisfy the downtime, downtime objective, or because it won't satisfy another constraint, whatever. You solemnly swear you'll test the restore and recovery operations frequently, and you'll also archive the WAL files between the beginning of the snapshot and now. I say now because most of the time when you want a VM on storage snapshot, you want to reduce the data loss. So in order to reduce the data loss, it means you will have to apply the WAL files between the beginning of the snapshot and the most recent operation before the incident. So how to perform restorable VM storage snapshot? The first way to do that is to take the snapshot offline. As I know, most of the time it's not an option. But stopping the database, taking the snapshot is a perfectly fine option. If you can't stop the database, then you need to take the snapshot online. To do that, you need to tell the database that you will be doing a snapshot. And so in order to reduce the risk of corruption of your backup, you will need to put your database in backup mode. You will do that with PG start backup, a label with the name of your backup, and the 2 false boolean beforehand. And then you will use the PG stop backup to put your database out of backup mode with the options false and true. I let you go to the Postgres documentation to understand these 2 booleans, but they're really important. And don't forget to also take the backup labels and the backup label and the tablespace map files that you will find on the PG data directory. Just for your information, depending on your workload, when the database is in backup mode, you might generate more WAL files. It's not guaranteed, but it can happen because you will enter a full page write all the time, so that it can be a problem for you. But don't you try to back up your database by doing a VM or storage snapshot without entering the backup mode, because you will end up most likely and more likely if you have a busy database with something you won't be able to restore. Physical backups. A physical backup is a set of consistent or inconsistent files that will allow recreating the cluster from nothing. You can have offline physical backup, so it's the same as offline VM or storage snapshot. You just stop the database and then you can copy over all your PG data directory and you'll be fine. But again, stopping the database to do a backup is most of the time not an option. So you will most of the time rely on online physical backups. There are several tools to have physical backups. PG-based backup is one of them, and I had a question about this one. And you have Barman, you have PG Backrest, you have others. The problem with PG-based backup is that it was totally designed for backup. It was not designed for restore. So it's lacking a lot of options like what backups have been taken. Is my backup corrupted? Well, now there is a verified backup tool, but you still don't have a catalog of backup. And how can I restore the backup? PG-based backup won't restore it for you. Just remember that creating a backup that the database can recover from is complex. Don't use your own scripts. That's very important, because I've seen people creating bash script on top of PG-based backup just to have a backup catalog, for example. This is a bad thing, because I assure you, backupping an online RDBMS is something very complex, and there are so many ways this can go wrong that I can't advise you to do that in production. Please rely on existing tools. When to rely on physical backup only? So again, all the following conditions needs to be fulfilled. You can afford the additional backup storage because it will take some size. Normally twice the size, you will need the same size as your primary PG data directory. You can afford the restore and recovery time, and you will be able to know that only should you test your backup. You solemnly swear you'll test the restore and recovery operations frequently. You'll also archive all of the WAL files between the earliest backup, I mean the begin of the earliest backup, and now. A backup without WAL files is totally useless because it's made of inconsistent file and you won't be able to reach a checkpoint. So let's compare. We have logical export, which are portable with a smaller granularity, but slow to restore, and with possibly a huge data loss. Standbys, quickly available. It's really simple to transform a princess into a queen, but it's on whole cluster only, and there is a huge data loss possibility. You need to take that into account. VM and storage snapshots, quickly available and reduced data loss. That's great, but it's for the whole cluster only. There is no WAL management in it, so you will need to do it yourself. You still need to recover. So even though restoring a snapshot is faster, you will need to apply all the WAL files, and a lot of things can go very wrong, believe me. And about physical backups, there are safe tools available. The data loss is reduced, but it's not zero, as I said first. That's not possible. And but it will work on the whole cluster only, and you still need to recover. So I will take some question now, and regarding time, I think I will have to follow up with the question I won't have time to answer.
Yes, let's see what's come through. A few people had questions about storage snapshots in cloud providers.
Yes.
One question was about reliability. Another was, do you know if any of the cloud providers provide storage snapshots?
Well, I know some, but the problem is they are closed source solutions, so I can't read their code source, their source code, so I can't certify the quality of the code. And so that's difficult to me to advise using such a solution for that reason.
Someone asked if can we back up standby cluster with BART?
Well, first, BART is deprecated. So I would advise you to move to another tool that will still have fixes in more than 18 months. And I think that BART can't take backup from a standby.
There's some roadmap questions. Let me see if what else has come through. Some of these we're going to have to circle back for. Someone asked about recommended books. We do have a blog post and an older webinar on demand about that Mark Linster did on his favorite PostgreSQL books. If you Google search that with EDB, I'm sure they'll come up. Let's see what else. There's a lot in here. A few questions came in about shedding more light on parameter WAL keep size in regards to WAL files.
Yes, I'd say that keep as much as you can afford. But should you have a standby, you should rely on replication slot. Well, again, it depends answer, because it really depends on your context, and you can be in a context where you can't rely on replication slot, and you should use an approximation with the whole keep size. So yes, it depends, and it would need to really understand what's going on and what would be the best option in your specific case.
Someone has the use case of they're doing a migration from an older version to a new version, and if there was a backup method that you'd recommend for that use case.
Well, first, before such an operation, I would back up my old cluster before everything. And there are several ways to use PG upgrade. There's one way to do it is just to use pgdump, pgrestore on the new cluster and you'll be fine, but it will take a lot of time. PG upgrade with link mode is particularly fast. So if you can't afford a lot of downtime, I really encourage you to look at the link option on PG upgrade.
Someone asked what a good strategy would be to test logical backups if you have several databases, since testing all at the same time could cause a storage limitation.
Well, I'd say that the first thing I'd say is, as I said, your backup strategy needs to align with your budget. If your budget is too low to buy more storage, maybe you should see your constraints another way and be okay with more data loss or more downtime. That's the first thing. The second thing is you can take several backup from several, but I don't know if you were speaking about taking several dumps of several databases at the same time, or if you were talking about backupping several clusters, different clusters on the same backup host. In that case, maybe you might be able to roll up your backups. But the thing is, the important thing is you can't do what's impossible. So you need to make sure that the money you get for the project aligns with the constraints you were given for that project.
Okay, so it looks like a lot of the other questions that are coming in are roadmap questions. We can circle back with the product team, and those will be some that we'll answer after the fact. And then the other ones, there's lots of like very specific use cases in terms of what you would recommend. So we'll probably circle back on those ones as well. But I just wanted to thank everyone for being here with us and for engaging and submitting all the questions. We will be sure to circle back on them. And thank you all for a great day, and we'll be sending the recording out later. So thank you all.
Yes, thank you, everyone.